All right.
Are we good? Are we good? Is it good?
Should be good.
Yeah. Hello. 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 Hello.
Go ahead.
Hello. Hello. Ah. Okay. We are on. So let's have a round of applause for our illustrious panel. Yay! So, without further ado, can each one of you just take a minute to just tell us who you are and where you're from and what you do?
Okay, so my name is Cecilia. I work for Taiko as a ZK engineer. And so what I do is that I write zero knowledge proofs circuits. And Taiko is a layer 2 ZK-Rollup featuring like decentralized provers and proposers. We're also a type 1 zkEVM.
Hi everyone, this is Rawi Agrawal. I'm Director of Growth at Polygon. So Polygon is a scaling solution on top of Ethereum. We got multiple scaling solutions right from the POS, which is one of the most adopted solutions, to this recently launched zkEVM, and then we also have app-specific chains. At Polygon, I am working as part of the growth team, where I'm focusing on newer areas like Web3 mobile strategy, AI, digital identity.
Hi everyone, my name is Dennis, and I'm from My Network. Actually, we are doing the data protection, and our product is a decentralized data lake. It is capable of privacy computing. We are using the technology of full homomorphic encryption and
Hi everyone, this is Joshua. I'm a co-founder and taking care of the strategy on zkPass. Basically, what zkPass does is, we are private data verification protocol. So you can think of maybe Chainlink is more on the public data. So zkPass is more on the private data. So which means if you have an account on any website, you are able to convert that piece of information within that account into a Web3 credentials. That's what we do. And we are using like TLS, NPC, and also zkP. So we recently launched a testnet. If you are interested in zkPass, just check the website and try it out. Thank you.
Hey, thank you. Hey everyone, my name is Vahe. I'm with Hexens. We do blockchain security, specifically ZK and cryptography as well. Smart contracts, blockchains themselves, whatever concerns applied cybersecurity. Yeah. So, and we have a bunch of questions to zkPass.
Thank you, everyone. Actually, these people are supposed to be on the panel, but they have to go. But quickly, just tell people what Desig is.
Oh, hello everyone. Wow, this is surprising. Hi, my name is Hannie. I am the co-founder of Desig. So we're working on a chain agnostic multi-sig solution empowered by MPC TSS. So our multi-sig solution is for DAOs, owners, project co-founders, and treasury managers. So that is all about Desig.
Thank you very much. So I am going to presume everybody knows what ZK is, and we're not going to do the basics again. So I'm going to go straight in and ask Ravi, how do you envision, I can't speak, how do you envisage zkPass evolving to address privacy concerns? And anyone else can actually come with this answer as well. I'm just starting with Ravi.
Yeah, I think when we are talking about privacy, I believe there are different layers of privacy. So, whether we wanted to have privacy for digital assets, whether we want to have it for data or for identity. And I think depending upon that, privacy can actually enable a lot of interesting use cases. So this is where, we are working very actively in terms of creating those proofs which gives zero knowledge to the users, and at the same time they will be able to verify it easily, right? So this can be applied across all those different categories that I mentioned. So how can I prove my data without sharing the actual data, and still the verifier should be able to prove? So, the most popular one that we all know is age greater than 18, right? If somebody here at the door, let's say, asking, show me whether you are greater than 18, we all end up showcasing our ID, right? And that exposes the amount of information that we don't want to do. Moving on from the data, the label of zero knowledge application in the identity side is also very interesting, where we can not necessarily reveal any kind of private information. And similarly for digital assets, how can I prove that I'm holding, let's say, 5 Bitcoin without expressing my wallet address? And those kind of privacy things can be very, very vital in terms of fostering the innovations and opening up a lot of interesting use cases.
Anyone else?
Well, in this era of like data overwhelmed society, I would say like all of the Web 2 companies are leveraging users' data to perform some large-scale computation for their commercial use. And I think the power of zkP with its current state of development is to shift like high throughput computation and completely privatize it without compromising users' own privacy. And so like the use of zkP for me, like the primary usage is scaling. So basically you're able to shift the heavy loads of computation from one party to the other, while the first party is able to like verify the computation with like constant time. Well, like privacy comes for free. So if you're able to like specify some input, most of the data as a private input, you'll be able to like perform the computation at the same time, hiding the input. So like for me, like that is like extremely powerful. Where in the future, users' privacy wouldn't be compromised while computation, the purpose of computation would be achieved.
Awesome. You know, we're going to get straight on to the obstacles and what may be blocking mass adoption and the uptake of zero-knowledge technology. So I just want to ask you, what are the main challenges and obstacles in the adoption of zero-knowledge proofs, and how might they be overcome? This is a big question.
Yeah, actually, in my opinion, one challenge faced by ZK is that I think ZK is the final step of computation, actually. For example, if Alice send a ZKP to Bob, all the computation must be done at the Alice side. Bob can do nothing but validate whether this validation is okay. However, in some scenario, for example, in the scenario of KYC, we actually have two phrases. For the first phrase, we need to validate whether the user's data, they are real, they are the genuine data. That's the first step. And that can be perfectly solved by ZK. They can be done at the Alice side and generate zkP, and then Bob can check whether it's true. However, in the scenario of KYC, the second phrase, we need to do the policy check. We need to check whether the data of the user meets the requirement of the risk control policy. However, the risk control policy it may change over time, and the policy of different group, different organizations, they are also not the same. So in that scenario, actually it's not proper to do the computation at the Alice side. So in this scenario, I think we actually had the solution for this kind of scenario by employing FHE with as a collaboration with ZK. We use ZK to solve the first step and use FHE to do the encryption over the privacy data. So that in the we can do the actually offline validation with ZK and do the online encryption with the full homomorphic encryption to solve the such scenario like the KYC.
I think when we're talking about those problems with ZK, there are a few items that we need to think about. The first one would be, the speed of proof generation. That's number one. Number two would be the speed of proof verification. The number 3 would be the proof size. How big is the proof? The 4th one would be how efficient, how much memory does this proof need to be taken on your browser base or on your computer base. So that's the 4 elements we need to think about when we, make a judgment on, if this ZK is good or bad. So basically, I think, in terms of mass adoption of zero-knowledge proof, I think we need to think about these 4 items. I think in the space, we already have some, ideas about how to make it zero-knowledge proof more efficient. Let's say I think, in terms of like a memory, let's say the 2 computation, MSS, and also the NDT, they take 80% of like a computation time. So I think if we are able to like multiply those, of NTT type of algorithm, which is able to reduce those computation time by 80%. So we do see some, adjustment or achievement in the space to make zero-knowledge proof more like a massive adopted. So I do see there's potential for the zero-knowledge proof to be generated by, very small memory. Like what we do in like zkPass, we basically able to like generate a zero-knowledge proof on the browser base. So actually it's a very memory efficiency. We used the Planck before, but now we are more on the interactive zero-knowledge proof. We recently updated technical white paper. If you guys are interested in how we did that one, I think you can take a look. I think so far, I wouldn't say we are number 1 to kind of engineering this, but I think it's a milestone for us. Yeah, thanks.
So I would also add that to what Joshua said is that in terms of, let's say, for one example of ZK rollups, there is also a thing that you most likely will want to decentralize your aggregator. And right now, for the rollups, most of the rollups at least, you really need like very big instances to actually prove the EVM work, as we're not that much efficient on the algorithms. And on the other side, the algorithms and the research is in a very fast pace. So I think we're kind of still under-researched in terms of ZK. And like eventually, you would want to come to a situation where a lot of devices, like you actually lower the proving time, the efficiency, you boost the efficiency, you can have aggregators in a very decentralized manner. A lot of devices should have the ability to generate the proofs so that, to add this additional, let's say even like layer of security in some sense.
I think I would like to add a user perspective as well. I mean, I totally agree in terms of the suggestions or the ideas that have been, discussed in terms of the challenges for wider adoption. But think about a user perspective. How many of us are actually reading the terms and conditions before signing up or opening an account?
Everyone's reading it.
That's an easy validation. How serious are we from a privacy perspective, right? So no matter, the tech enhancement can continue to develop, but I think the user behavior in terms of seriousness about privacy, that has to be also educated, that has to be made aware. And that's where, when the users are equally aware about usage of this technology, that's where we would see an uptick into the adoption. Otherwise, I think technology would certainly be built, but the user awareness and education is equally important.
Awesome. Do you want to say something, Celia?
Yeah. So I agree with your take on like the user adoption, because I'm also a contributor of like a zkML project hosted by PSE, which is zkEVM. They're currently covering like most of the cases of like on-chain machine learning inference circuits. However, they're striving to find adoption. So what they realize is that like we have this powerful tool chain of like being able to prove that certain data is like, for example, is indeed generated by ChatGPT, GPT-4 instead of GPT-3. Well, they don't find enough adoption from the user. Like the user is also, we're still like finding use cases of like, why do we want our computation to be proven, right? So I think for us who grow up in this Web 2 ecosystem, we need to like cultivate the user to in this like trustless environment. We need to tell them you can't take trust for granted. Like the computation that you delegate to some Web 2 institution or even Web 3, whatever intermediary, cannot be taken for granted, right? You have to ask for a proof. And that's what motivates development and research. So I think like that's one obstacle of zkP itself, is the adoption. Yeah.
Awesome. So we talked about what may be holding us up in terms of zero-knowledge proof technology. But let's talk about now the new stuff. What about the innovations? You know, can you let us know if there are any recent or upcoming innovations in zkPs that you find particularly promising or exciting? Like, what's the new trend? Specifically, maybe in zkEVMs or something similar.
Okay, so this is the easy one. So recently, we have foldings. Like there's a lot of folding scheme appearing, starting with Nova and then Supernova, Hypernova, Sangria, and like Protostar. All these recursive proof technology will be able to like fold multiple proofs together into one proof while maintaining the verification time to be constant psi. And I think like this is a very powerful technology because it's even a more scaling of how much data you can batch and you can prove at once. And I think eventually after these technology become mature, we will finally be able to like integrate zkP into modern data pipeline, right? Like making the use of zkP in actually how we process data in Web 2, for example, machine learning. Yeah.
I think I would divide this question into two parts. So uses of zero knowledge in terms of how can we leverage it for scalability? That's one aspect. I think that's something that we have been discussing in terms of how ZK rollups are actually going to be the end game, right? Something that Vitalik keep talking about. How can we achieve the kind of scalability that we all wanted to have? Switching it to the other part, how can we use zero knowledge even for privacy aspect? And that's where I believe there are very innovative use cases that are coming out. Again, quoting up Vitalik, what he has been recently published in his white paper in terms of how can we use zero knowledge in terms of identifying whether the source of funds are all legit. And that's where if those source of funds are legit, can we bring them into the ecosystem? And that's where we will not have the issues what we have seen with the systems like mixers in the past, right? And we all know the story. Without quoting an app name, I think those kind of situations, how can they be avoided? And the innovation in the Web3 can work and coexist with the existing financial services. Even the innovation in terms of how can we leverage AI, for example, in terms of creating those ZK-based chatbots or ZK-based assistants. And going it further, I think this technology can do real wonders when there is innovation where we can bring in the Web2 data also into Web3 without actually revealing up the data. So very excited about the innovations happening in this space.
I think the innovation recently is more regarding, as far as I know, it's more the area we are interested in is how to make ZK more efficient. So the way we do it is kind of like getting rid of interactive zero knowledge, so reduce kind of like a communication between governor and the verified. So basically, each of them kind of computing a lot of like mathematical things locally because they are using kind of the same equation without communicating right between those two parties. That's some innovations that we are looking into in terms of like technology. But I think more important would be those user cases actually, how to bring like a user awareness to understand how ZK works and how to use ZK in a real life scenario. I think we already get into a space, let's say, in the real life, you get those walls protecting your privacy, right? On the internet base, we definitely have something to protect your privacy, and in a way, all the members, all the parties are very comfortable with. I think, yeah, I do see ZK has a bigger potential for this, and yeah, I think the last thing would be we're talking about technology. I think we more concerned about the regulation side. Let's say if I submit a proof, right, and how does the government to acknowledge, okay, this is the proof, and how to let's say against those AML type of regulations. That's something we are thinking of as well.
Okay, so let's talk about the broader tech community and what we can do to contribute to the advancement of zero-knowledge proof technology. So I know, Rawi, you might have some insights into what are the best practices for a thriving ZK ecosystem. What can we do to supercharge innovation? And because we're like way over time, this is going to be the last question. So just have a little think about that. But Rawi, I'm going to start with you.
Certainly, yeah. I think to me there are two components that we can use an opportunity to supercharge. One is how can we create more and more open source component? How can we have the community participation into it? How can we have those thousands of brains coming together in order to create a foolproof system? So open sourcing is one. Second is standardization. How can we improve the developer experience by creating certain standards that makes the life of a developer super easy in order to use that, adopt it, quickly implement it. And I think that's where the Web3 comes very handy, where we can really make those systems composable with the help of making those open source components which are following certain standards. So I believe that's my 2 cents or 2 GUI in terms of making it supercharged.
Yeah, actually, I think the advancement of the zkP can be improved in 2 aspects. First, we can find more scenarios. For example, currently zkP is mostly used for blockchain. However, we can do some move to some new type of chains. For example, IoT blockchain. Actually, I was a security researcher in IoT security, and in IoT they faced a major problem is that their information channel is insecure. So this brings 2 problems. Actually, the first one is that the credentiality, and the second one is the integrity. This means that for some IoT device which may be very sensitive, for example, the IoT device which is wearable and the medical device, there are a lot of privacy-sensitive information be transmitted. However, they are probably transferred in an insecure channel. Then zkP can help to improve such kind of situation, because we can just move the validation into the very front end of the device side when they collect data, and we just generate a zkP, and we do not have to transfer the real sensitive information, and just send back the proof to the backend, so that the sensitive information can be just well protected. And another problem is that the integrity, because the data they may be manipulated. With the zkP, we just transfer the proof, which can also solve this kind of the problem. This is from the application side. And from another side, I think, from the technology side, I think ZK is very, actually it's currently very popular, and it has a lot of advertisement. However, since it's only one single technology, it has some limitation. So we are working to just combining ZK with other privacy computing technologies. Actually, we are working on FHE. So we are combining this FHE and the ZK. We do encryption with FHE and do the validation with ZK. This can solve a lot of scenarios which we previously cannot solve. So I think for other developers, they can just also collaborating with ZK with other technologies and then broaden the scenario which we can adapt to. Yeah, that's my opinion.
Awesome. Any more?
Yeah, so I think there are three perspectives in terms of improving the ZK landscape. So first of all, it's like from the user perspective, which is the UX. We need to like educate our user to like adopt the idea of trustless computation even more. And then more importantly, I think we need to separate the landscape of research and engineering. So for engineers, we have developers who develops like zero knowledge circuits front end, and I think like we need to develop like paradigms for a software engineer in terms of ZK proofs generation. Like what is considered to be a legit proofs of certain business logic. I think this sort of standard should be established for better auditing and upgradability purpose, and also for research. There's also like different research aspects. For example, some people are working on hardware acceleration, some people are working on protocol development. And there's like different layers of optimization that can potentially have. I think in the future we need to like further modularize all these specific tracks and regulate them and standardize them. And with like this like specific tracks of like modularity, we'll be able to compose ZK technology even better.
Thank you very much for that. We're going to kind of wrap up now so we can get to drinking and chatting and listening to some good music. But I want each of you, just 30 seconds, call to action. I'm going to start with Hexens. What do you want people to know? How can they reach you?
How can they what? Sorry?
Yeah.
How can they what?
How can they reach you? So just
Yeah, sure. Just you can reach me out on the website. I mean, we have request form there. Nothing too hard. I just want to add one word about the recent topic real quick. So I think one of the things that should be improved in general, especially for the community, is the education part, because it's not like too easy to actually start studying and diving deep into the ZK technologies. The information is really very scattered and not too easy to collect and comprehend. And I think there's still a lot of things that can be done and improved in that direction. Yeah.
Awesome.
Thank you.
zkPass.
All right, zkPass. We have a few members in the audience wear zkPass t-shirt. It's very easy to recognize. If you guys want to talk to us, we are obviously open to talk to you, and we have the testnet already up. If you are interested in try the product, especially try to log into your Binance account and then transfer your Binance security level into a Web3 credentials. Log into your government website. Your government, let's say here, you get a SIM-pass, right? Log in, and log into your UOB account, log into your Bank of America, whatever. And then you are able to generate a credential to represent your real life identities. All right, that's it.
I'm from My Network, and actually you can reach us through our website, mynetwork.xyz. And actually, we have already. Actually, we are still in testnet, and we have already released our SDK. So if you want to have a try, and you can just import our SDK into your D app, and that can interact with our MindLake product. And besides the product, we actually are working actively in the Ethereum research community. We are doing researches regarding full homomorphic encryption, witness encryption, and actually cross-chain bridge and stealth address. we actually posted several papers in the Ethereum research blog. Yeah.
And in terms of reaching out to Polygon, I think there are several channels that can be leveraged: Discord, Twitter, on the website. In fact, we have launched something cool which is called as Copilot. This is going to be an AI-based assistant for many developers as well as enthusiasts from the Polygon ecosystem to leverage it and ask for anything that you need. And in particular, if you have anything in particular to be discussed, always available. Happy to connect and take up any questions from your side and help you navigate from Polygon ecosystem perspective.
Okay, so here in Singapore, you can reach Taiko by looking for the pink shirts. I guess we're the only team who's wearing pink shirt in all of different sizes. Yeah. And if you're online, go to taiko.xyz. Our A5 testnet currently on. We're testing like decentralized proposer improver. I think that's pretty cool. You guys are all welcome to try out proposing some blocks, improving some blocks. Yeah. So yeah, that's it for me.
Awesome, thank you very much. Let's have a round of applause for our illustrious panel. Thank you, Hexens, Desig, zkEVM, Mind Network, Polygon. So we can turn on the music now, right? Thank you, guys.
Thank you.